All right, how do we factor this? Yes?
A, or your A is X, and your B is 3, and then plug it in. A minus 3.
Good.
And then do opposite sign.
Good.
Sign.
And then what happens in the back? Good. All right, so that's how we factor it. Anytime you're solving, you want to factor first, or at least attempt to factor first. And then you're going to set each factor equal to 0. So in the first one, I'm getting positive 3. The second one does not factor any further because there are no two numbers that multiply to give me 9 but add to give me 3. So I'm going to use the quadratic formula. So I have negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 9, all over 2 times 1. What am I going to get inside the parenthesis, or sorry, inside the square root? A negative. So what type of solution will this be? Imaginary. Do I care about imaginary solutions for this example? No. So I'm not even going to finish doing the quadratic formula. Once you see that it's an imaginary solution, you can forget about it because the directions tell you to just find the real number solutions. So the only real number solution to this equation is 3. Today we're graphing polynomial functions. If you wanted a section number, technically this is part of section 6.2. However, I wanted to solve equations. You'll see why. If you can solve these equations, it makes graphing them a little bit easier. So we're going a little out of order here because we already finished 6.4. Now we're going back to 6.2. But this is all about graphing polynomial functions, and our goal is pretty simple, to graph polynomial functions. All right, here are the steps to graphing polynomial functions. The first thing you want to do is you want to predict end behavior based on two things. You want to look at your lead coefficient and the degree of the polynomial. We talked about that when we did 6.2 the first time, the end behavior. I believe it was 2 Fridays ago when we talked about it. So I know you might be a little rusty. We're going to review that step a little bit. But the first step, the end behavior, will tell you what your graph should look like as you get to the left end of the graph and to the right end of the graph. As you're going farther into the negative x's and farther into the positive x's, that will tell us what we should see in those directions. Step 2 says find the real number zeros. The real number zeros are the same thing as saying the x-intercepts. So for example, on our warm-up, we got 3 as a solution. 3 would be my x-intercept. And you find x-intercepts from making y equal to 0 and then solve the polynomial like we learned yesterday. Sometimes you can't factor it, sometimes you can't solve it, sometimes there's not much you can do with step 2. It's kind of a nice starting point though. Anytime you're stuck though, or if you need more points, just make an XY table. I know you guys aren't huge fans of XY tables, but with polynomial functions there's not much you can do without the XY table. So definitely investigate your function using an XY table, and then you're going to plot all the points and connect it with a smooth curve. Polynomial functions are very curvy. You can see there's some on the board behind you. The class in front of us was doing this. So they should all be very smooth. Don't make it like one of those connect the dots drawings that you did when you were little. It doesn't look like that. It's a smooth curve. Any questions on these? All right, I want to review what we learned about end behavior. So here's a little chart that I think might help you. End behavior of a graph is determined by two things: the degree of the polynomial and the sign of the lead coefficient.
Is it like this?
We did this, yeah, a couple weeks ago. You'll probably have this in your notes already somewhere. If you don't, I would definitely include this. All right, so first I want to look at when the degree is odd. That means when your largest coefficient is an odd number. Remember, the easiest odd number polynomial we know is just linear graphs. So think of what you know about linear graphs and how they look towards the far left and the far right as you're going through this. If your lead coefficient is positive, again, think of a linear graph. So what's the slope? The slope is what would be positive if we were looking at a linear graph. As you go to the far left side, your graph is going down. So that means your graph is approaching negative infinity. Again, just think of a line here with a positive slope. When you go to the far right side of your graph, as the x approaches infinity, so does your function. And remember, this is only telling us about the end behavior. So the left side of my graph, I'm approaching negative infinity. That just basically means your arrow on the left side should be facing down. The arrow on the right side should be facing up. Remember, end behavior doesn't tell us anything about the middle section of the graph, just what we should expect to see on the far left and the far right. If our degree is odd, but our lead coefficient is negative, it behaves similarly to a linear graph with a negative slope. I'll sketch it for you real quick. If we had a linear graph with a negative slope, on the far left side our arrow would be pointing up, and on the far right side our arrow would be pointing down. So this is telling us the left side. Remember, it says as x approaches negative infinity, which means as you're going to the left side of your graph, what is your function doing? Well, it has an arrow going up, which means it's approaching positive infinity. And as you go to the far right side of your graph, your arrow is going down, which means it approaches negative infinity. Any questions on those? All right, now we're going to look at even degree polynomials. Again, when the lead coefficient is positive and when the lead coefficient is negative. I think it's easier to sketch the graph first, so I'm going to go ahead and do that. The end behavior of any odd degree polynomial we said is similar to a linear graph. Any even degree polynomial is similar to the parabolas we were just graphing in chapter 2. So remember, when the lead coefficient or when the a term was positive in our parabola, the arrows were both facing up. So whether you were approaching negative infinity with your x values, meaning you're going to the left, your arrow was going up towards infinity. To the right side of your graph, your arrow was still going up. But remember, with our graph transformations, we know that if A switches signs, if A becomes negative, your graph just flips across the x-axis. So now both sides would be going down. So whether you're going to the far left or the far right, both of your arrows, your end behaviors, would be going down. So they'd be approaching negative infinity. So anytime we're graphing a polynomial function, I want you to look back and remember what we know about end behavior, because we're going to need to do an XY chart to figure out what's going on around the origin in the middle part of our graph. But if we can predict the ends, that'll help us in the long run. Any questions on these? Here's our first example. If you guys looked at your revised schedule for Chapter 6, we are spending 2 days on graphing. We're going to do 8 examples today, and I'm going to give you an assignment. I'm not sure if we'll get to new examples tomorrow. These take some time, so tomorrow might just be a homework day, depending on what you guys need. We do have a homework check Monday, so if you guys want more practice tomorrow, we can do that. If you want to just work on homework, we can do that. But just kind of let me know where you're at tomorrow, and we'll figure it out from there. But like I said, these take some time. So don't try to rush. All right, the first thing I want to talk about is end behavior. So this is an even degree function with a positive lead coefficient. So what should the end behavior look like? Yeah, similar to a parabola facing up. Okay, so in the end, I should have two arrows, one like this, one like this. I would not draw these on my graph right now. I would just keep that in mind as you're going through this. If the ends don't end up looking like that, we made a mistake and we need to go back, okay? So when we're doing end behavior, it's just going to be a lot of talking about it. You can make little notes to yourself, but it's just kind of predicting what our graph should look like. But I'm going to get rid of those because we haven't really calculated anything. It's not very precise. All right, the next thing we want to do is see if we can find out where the x-intercepts are. To find x-intercepts, you make y equal to 0 and you solve. Well, we can't really factor this, right? So does anyone know if y is 0, what x has to be? 0. Yeah, this one, the x-intercepts, it's not really tricky. It's just 0, 0. So I know I'll have a point at 0, 0. Whether you make x 0 or y 0, the other one has to be 0. They're 0 and 0 together. Okay, I'm kind of stuck. The only real other thing I can do here is just make a table. Yeah, 1's a good place to start. When you put 1 in for x, what do you get for y? 1. Okay, when you put negative 1 in, what do you get? Same thing, 1. Negative 1 to the 4th is still just 1. All right, what else? 2, sure. 2 to the 4th is 2 times 2 times 2 times 2. Yeah, you get 16. Same thing for negative 2. We'd already be off the graph. Whoops, that should be positive. Okay. Now, this kind of seems like it should just be a parabola, right? So I'm not getting a whole bunch of information. I want to see, though, what happens in this little space right here. Okay, sometimes we want to investigate what's happening in between. We want to be really precise here. So can someone just type in their calculator really fast, 0.5 to the 4th power? .0625. So you can kind of see that it stays pretty close to 0 until you get to the 1. So it's kind of, you can't really see it in my graph. We maybe should have done our scale a little larger than 1. But it's kind of flat until you get to the 1 and then it shoots up. Okay, and then we know that by the time we get to 2, it's all the way off the graph. So we're going to shoot up really quick. So between 0 and 1, it's kind of flat. And then once you hit the 1, it just shoots up. Now, does this match our prediction of the end behavior? It does. Good. What are your questions on this one? Now, I will be completely honest with you guys. When I first learned how to do this, I was very dependent on my calculator. If you have a graphing calculator, this is already in y equals. So you can double check your graph by just typing in y equals x and then that little caret symbol 4, and then hit the graph button, and it should show you a graph that looks like this. These get very complicated. If you want to check your work with a calculator, great. If you don't have a graphing calculator, jump on the website Desmos and check it that way. Okay, it's very easy to make mistakes here. Like I said, these are kind of challenging. So just remember, go slow, check your work if you need to. Any questions on this one? All right, here's number 2. All right, the first thing I want to do is predict the end behavior, just so I can kind of double check myself when I get towards the end of this. My degree is odd, and my lead coefficient is positive. So what should the arrow to my left side of the graph look like? It should be going down. So I know I'll have one kind of over here. And then as I get to the far right, what should my arrow look like? It should be going up, okay? Again, you don't really have to put these in there now. You can make a little note just like I did if you want, just to kind of double check yourself as you go. But we should have end behavior similar to a linear graph. So as you're going to the left, your arrow should be going down. As you're going to the right of your graph, your arrow should be going up. But I am just going to, I'll leave them just to kind of keep a note of it. Now, is this something I can factor when I set y equal to 0? Not really, but what do I know my solution has to be? 0, okay? X and y are 0 together. So I will have a point at 0, 0. That is definitely not always the case, but these first couple ones we're going to look at, it will be the case. Yep, now it's time to make our table. I guess we'll start with 1. When you plug positive 1 in, what do you get? 1. Should we plug 2 in? What would I get? 8, good. If you plug 3 in, you'd get 27. So we're kind of maxed out on our right side. So what happens when I plug negative 1 in? You get negative 1. And when you plug negative 2 in? Negative 8 this time. Good. All right, so that's really the only points I can fit on here. You could plug in fractions to see how it behaves in between. I'm not sure if that's completely necessary on this one. But remember, it's a smooth curve. So don't just connect the dots. It's kind of like an S-looking thing. Like that. Does our end behavior match our original prediction? Yeah, so we know we're good. What are your questions on this one? Yes? But since this is an even degree polynomial with an with a positive lead coefficient, this is just going to be a parabola going up. So arrow to the left, up, arrow to the right, up. Let's see if we can find where it hits our x-axis by setting y equal to 0 and solving. So what are my x-intercepts? 2 and negative 2. Good. So along my graph, I'm going to put a dot at 2 and a dot at negative 2. All right, that's all we can really get without an XY table. If you don't know what's happening on the y-axis, that needs to be the first number you plug in. Start with 0 if you don't have information about it already. On the previous two examples, we knew exactly what happened when y was 0 because x and y were 0 together. But on this one, definitely plug 0 in first. What happens when you plug 0 in? You get -4. So my y-intercept is -4. All right, let's go ahead and plug 1 in just to see if there's any weird bends and curves going on here. When you plug 1 in, what do you get? -3. When you plug -1 in, what do you get? -1 squared is 1, and then 1 minus 4 is still -3. So no real surprises here. Alright, if you wanted to keep plugging things in, you could, but we know already this is just going to be a parabola because the degree is 2. So you can go ahead and draw your arrows in. Does this match the end behavior that we predicted? Yes, it does. What are your questions? All right, here's number 4. All right, first thing I want to do is predict the end behavior. This end behavior will be similar to what? A parabola with a positive lead coefficient. So on the right side, I should have an arrow going up. On the left side, I should also have an arrow going up. All right, let's see if we can find any x-intercepts. If not, we'll just start using a table. To find x-intercepts, you make y equal to 0 and then see if we can solve. Does this factor? How? Multiply, add. Good. Multiplies to 6, adds to -5. Yeah, so this is going to be x squared minus 3, x squared minus 2. After you factor, you can set each of those equal to 0. And then we can solve. So we have 3, then take the square root. So we have an x-intercept at plus or minus 3, plus or minus the square root of 3. And plus or minus the square root of 2. All right. What is the square root of 3? Do it on your calculator. Yes?
I don't get like your third step.
So all I did there was I graphed positive square root of 3 and negative square root of 3. They're right around 1.7, so it's almost to the 2 in the positive direction, almost to the 2 in the negative direction. What is the square root of 2? 1.4. So we'll have one closer to the 1 and closer to the 1. It's a weird graph, isn't it? Alright, I'm going to make my XY table. I'll probably need to extend it a little bit. That's not going to give me room for many points. We don't know what's happening at 0, so let's plug 0 in for x to find where it touches my y-axis. When you plug 0 in for the x, what do you get? 6. So I'm going to be all the way up at the 6. Do I know what's happening at 1 and -1? Not really. I can probably guess, but let's go ahead and get some more points. Let's plug in 1 and let's plug in -1. What do you get when you plug in 1? I think you get 2. Because 1 to the 4th is 1. 1 squared is 1. So you'd have 1 minus 5, which is -4, plus 6 is 2. Oh, okay. So you should get the same thing when you plug in -1. So I have a point at 1, 2, -1, 2. Alright, I'm out of space on my XY chart, so I'm going to start a new one up here. I want to know what's happening between the square root of 2 and the square root of 3. We said the square root of 2 was around 1.4. The square root of 3 was around 1.8. So let's plug in 1.5 and see what we get. Are we still at the 0? Is it like a straight cut over? Or does it like dip below the x-axis there? I need to know. And if it goes below the x-axis, how far below? It's just a little dip. Is it like all the way down to -3? I'm not sure. So someone type that into the calculator. 1.5 to the 4th minus 5 times 1.5 squared plus 6. Anyone have it for me? So when you plug in 1.5, you get what? -0.
1.187.
Okay, so it's just going to dip right below the x-axis. Now, you could plug in 1.6, 1.7, any point between the square root of 2 and the square root of 3. If you want a little more detail, that's enough for me just to kind of tell me that it's going to dip just right below the axis. So when I'm making my curve, I'm going to make sure I go just a little below and just a little below. Alright, now after I do those square roots, square root of 2 and square root of 3, I need to see where the end of the graph is going to go. So let's plug in 2 and -2, and then we'll plug in 3 and -3, and then that should give us enough. Remember, you want to be able to explore all the curves happening in the graph before we're done. So don't just say, oh, it's a minimum of 5 points, or I need 3 points, or whatever. I can't tell you a set number of points you need for each graph. It depends on how complex the graph is. Okay? This one, you can't just say, oh, it's going to curve here, and then stop. We need to explore it a little more. So can someone plug in 2 for me? Plug in 2? What'd you get?
I got 2.
When you plug 2 in, you get 2. When you plug -2 in, you should also get 2. Okay, so now it's up here and here. Alright, let's plug 3 in and -3, and then we should be done.
Do we have to plug this many points in? Or
Yes.
I feel like I could definitely see what way it's going. Like,
What'd you get, Tyler?
42.
42. Whoa, so it's like shooting straight up, right? All right, so that's basically where my arrow is going to go. All right, now here's the tricky part. We need to connect all of this with a smooth curve. Now, I'll give you guys a hint. Your degree, here our degree is 4. Take 1 away from that. That's the most number of curves you should see. So when your degree is 4, the most number of curves you should see is 3 curves. When our degree is 3, you should see 2 curves, kind of like an S. When our degree is 2, you should only see 1 curve. When our degree is 1, you should see no curves. Okay, so it's always just 1 less than this degree is the maximum number of curves. Sometimes there's less curves depending on how complex your equation is, but that's just kind of a guideline for you. What are your questions on these? Let's try to squeeze one more in, and then we'll save the rest of the examples for tomorrow. All right, the first thing I'm going to do is just predict the end behavior just to kind of give myself a good check as I'm going along. So this is an odd degree polynomial with a positive lead coefficient. So what should my left side arrow be doing? Going down. What should my right side arrow be doing? Going up. Okay, so I'm just going to make those little notes. Those arrows are not part of my graph. They're not part of my answer. They're not really anything. They're just a way for me to check to see if everything makes sense when I'm done. Okay? Now, let's try to find where it touches the x-axis. So I'm going to make y equal to 0 and see if I can solve. Well, this is a difference of cubes, right? So I can factor it. So I'm going to have x minus 2, x squared plus 2x plus 4.
Why we do that in the last parenthesis?
Once you factor it, set each factor equal to 0. So I get 2 as a solution. This does not factor, so I'm actually going to set up the quadratic formula. If you realize at any point that it's going to give you imaginary solutions, you can stop. So let's just give ourselves a quick check. This is going to be negative 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times 4. Are we going to get a negative number in the square root? Yeah, so we can just stop. As soon as you see that that's going to be an issue, just stop. We're done. We have one x-intercept. It's at 2. All right. Now all we can really do is do the xy table and just kind of fill in the gaps. I told you you always want to plug 0 in first if you're not sure what your y-intercept is. When you plug 0 in, what do you get? Negative 8. So I have a point down here at negative 8. The obvious next choice is 1. When you plug 1 in, what do you get? Negative 7. Okay. All right, let's plug negative 1 in. Negative 9. Good, because you get negative 1 minus 8. Okay. What else do you guys think? 3? 19. Okay, so we're going to be off the graph. And then I'm assuming when I plug in -2, I'll be off the graph as well. That'd be -16? Yeah, so I'm going to be off the graph as well. So let's go ahead and fill it in. Smooth curve. Mine's not very smooth there towards the end. Let me fix that. All right, does it match the end behavior that I predicted? It does. Good. Now, let me just point something out. We, earlier today, graphed y equals x to the third. It should have the exact same shape as this graph, except this one is shifted down 8 units. It has the same graph transformations as those quadratics that we looked at when we did all those things on the laptops last chapter, I mean. So this is just the same graph shifted down 8 units. So don't forget what you learned about graph transformation. It will help you keep a good check on your work here. Any questions? Here's your homework. This is going to be your homework for today and tomorrow. It's only the odds. It's from section 6-2. It was up on the board when we did the revised schedule for this chapter, but it was not on your green sheet originally, so you might want to write it down just in case. There's extra graph paper up here. But again, this is your assignment for the next 2 nights. As we were going through this, it took even more time than I had anticipated. So I'm not going to give you additional work tomorrow. We'll just keep going with this assignment. Any questions?